It's not the heat, it's the humidity, the saying goes. That's true for people, but especially true for spacecraft. Florida is known for humid summer days. It shouldn't be surprising that engineers designing spacecraft know this too and design their vehicles accordingly. So it was a little perplexing when Boeing and NASA engineers found the reason for stuck oxidizer valves in Starliner's propulsion system, which caused the 9-month delay for what is already a do-over flight, was ambient humidity. However, solutions to this problem have been found, and NASA and Boeing say they are ready for the next attempt at the second uncrewed orbital flight test for the Starliner spacecraft. If the week-long flight to the International Space Station is successful, it sets the stage for a crewed flight test later this year and operational flights sometime next year. In this video, I'll explain what happened to Starliner last August, how Boeing plans to prevent the issue from happening again, and why getting the spacecraft flying safely is important for NASA's access to the ISS. Who would have thought 3 years ago SpaceX would have launched 7 human spaceflight missions before Boeing would complete a single fully successful uncrewed Starliner orbital flight test? Sure, it may have been predictable that SpaceX would have most likely been first in the commercial crew program, but first by 3 years? For those not familiar with Starliner, it is the second of 2 human-rated spacecraft in NASA's commercial crew program, the other being SpaceX's Crew Dragon. In 2014, NASA awarded Boeing a $4.2 billion contract to develop Starliner. SpaceX was awarded $2.6 billion. The original goal was to have one or both vehicles certified for human spaceflight by 2017. SpaceX and Boeing have both experienced setbacks and delays with their designs. Starliner has 2 main parts, a crew module and a service module. The crew module is a conical-shaped capsule with a diameter of 4.6 meters. Combined with the service module, the stack extends to 5 meters tall. Overall, Starliner has a mass of 13,000 kilograms and a habitable volume of 11 cubic meters. The propulsion system in the single-use service module includes reaction control thrusters that use hydrazine fuel and dinitrogen tetroxide oxidizer. It also has 4 larger abort motors that could be used in the event of a launch emergency. The base of the service module also has a series of solar cells in order to power the spacecraft while in free flight. It has a design life of about 60 hours in free flight and around 210 days docked to a space station. At the top, the crew module has a docking port to allow it to link up with one of 2 international docking adapters on the ISS. Starliner can hypothetically hold up to 7 people. However, NASA is only expected to ever utilize a 4 or 5 person configuration for regular space station crew rotation missions. Boeing has said it is willing to sell the extra 5th seat to potential commercial and government-sponsored astronauts or even private spaceflight participants. The crew module has a heat shield to protect it during re-entry into Earth's atmosphere. Additionally, the capsule is equipped with parachutes and landing airbags to perform a soft touchdown on land in the western United States after a nominal mission. Boeing says the Starliner crew module is designed to fly up to 10 times. As such, Boeing has plans to alternate between only 2 capsules, the as of yet unnamed Spacecraft 2 and Spacecraft 3, which has been named Calypso. Spacecraft 1 was used during a pad abort test in 2019 and then retired. To get into orbit, Starliner utilizes United Launch Alliance's Atlas V rocket in a special configuration called N22, which means it has no payload fairing, 2 strap-on solid rocket motors, and a dual-engine Centaur upper stage. Starliner missions fly from Space Launch Complex 41 at Cape Canaveral Space Force Station, which is just south of NASA's Kennedy Space Center where SpaceX launches its Crew Dragon. Boeing has signed with ULA to launch Starliner atop Atlas V through the 6th operational Starliner mission. After that, it's likely the spacecraft will launch via ULA's upcoming Vulcan rocket. However, that has yet to be officially announced. The development of Boeing's Starliner spacecraft hasn't been smooth, to put it mildly, but it is of extreme importance for the spacecraft to be successful if NASA is to have redundant access to low Earth orbit. If you agree, be sure to launch this video's like button into orbit. Maybe it'll help get Starliner into orbit too if we're lucky. I covered a lot about Starliner's development process in a previous video. Be sure to give it a watch, as I'll only briefly touch on some of those points in this video. You can see it in a link in the description below. In November 2019, Boeing performed a pad abort test on its Starliner spacecraft. It was deemed a success, however, one of its 3 main parachutes did fail to deploy. While the malfunction wasn't supposed to happen, Starliner is designed to safely land with only 2 parachutes. A month later, in December 2019, Starliner was finally ready to fly an uncrewed capsule to the International Space Station. The mission, called Orbital Flight Test, used Spacecraft 3, which was later named Calypso. SpaceX successfully performed its uncrewed Demo 1 flight in March of 2019. While being behind only 9 months, there was still a chance that Boeing's design could fly crew before SpaceX, since a month after the Demo 1 flight, that same capsule exploded shortly before a static fire test of its abort motors. The company was planning to use that capsule for its in-flight abort test. However, the loss of the capsule and subsequent investigation delayed the company's plans by many months. If Starliner successfully completed its uncrewed test flight, it might have been able to get a crewed flight test launched in fairly short order, but it wasn't meant to be. While the Atlas V rocket performed flawlessly, several programming errors in Starliner resulted in the spacecraft barely scraping its way into orbit. Because of an issue with Starliner's mission elapsed timer clock, the service module's maneuvering thrusters fired and placed the spacecraft into an incorrect orbit. Moreover, it used too much fuel to make it to the International Space Station. Instead, the spacecraft was commanded to return to Earth just 2 days after liftoff, landing at White Sands Space Harbor in New Mexico. Following an investigation, Boeing announced it would refly the mission at its own expense, costing some $410 million. It would be called Orbital Flight Test 2. NASA called the OFT-1 mission a high-visibility close call, since the whole spacecraft could have been lost. Needless to say, shortly after Starliner landed, Boeing said it achieved more than 60% of its flight objectives. It was more than a year and a half before Starliner would again reach the launch pad. During that time, SpaceX launched not 1, but 3 human spaceflight missions to the ISS. In the summer of 2021, Boeing and NASA appeared ready to finally fly OFT-2. It was stacked and rolled to the pad in preparation for a launch on August 3rd. It seemed the spacecraft problems were behind it. However, just 5 hours before the planned liftoff time, engineers detected unexpected valve positions in the spacecraft's propulsion system. As such, the launch was called off and delayed indefinitely. The Atlas V and Starliner spacecraft were rolled back to ULA's Horizontal Integration Facility. Over the coming days, it would be found that 13 of 24 valves in the service module's propulsion system were stuck. But to get a better understanding of the nature of what was causing the valves to be stuck, the spacecraft was removed from the rocket stack and returned to its hangar, which is located at the Commercial Crew and Cargo Processing Facility at NASA's Kennedy Space Center. Over the course of several months, engineers removed several stuck valves for analysis and eventually found that the valves were stuck because of corrosion, likely caused by ambient moisture making its way into the propellant lines. According to Boeing, the dinitrogen tetroxide oxidizer was loaded into the spacecraft around 46 days before the planned launch. It combined with ambient humidity to create nitric acid. It was this that began the corrosion process inside the valve's aluminum housing, preventing them from cycling open or closed. The service module originally tapped to fly the OFT-2 mission was removed, and now the service module that was scheduled to fly with the crew flight test is now being used for OFT-2. In a May 2022 teleconference, Boeing and NASA said the valves on the new service module are the same design, but any potential pathways for moisture have been sealed. Moreover, the propulsion system is expected to be purged of any moisture using nitrogen gas before the actual propellants are loaded, which is now being done closer to the actual launch date. But that is apparently a short-term fix, and Boeing hasn't ruled out a long-term redesign of the propulsion system following the OFT-2 mission. Regardless, NASA and Boeing say they are ready to fly OFT-2 this month. But I have to ask, like many are probably asking, why did it take until 5 hours before a planned launch to realize that ambient humidity potentially getting into the propellant system was a problem? I know these things happen, but a lot of things seem to have happened to Starliner over the past few years. During OFT-1, it was ultimately an error with software and the onboard mission clock that prevented the spacecraft from entering the correct orbit. Another software issue, which was thankfully caught and corrected during the flight, could have resulted in the service module crashing into the capsule after separation following its deorbit burn. That would have potentially caused the loss of the whole capsule. From what I understand, most if not all of these software problems could have been found and corrected had Boeing engineers performed more thorough software tests on the ground. In fact, there was no end-to-end test of the entire software suite, according to Boeing. NASA isn't out of the woods for the blame game either. After OFT-1, an investigation showed that the space agency should have had a more direct oversight process. During a media teleconference on May 3, 2022, in the lead-up to this second attempt to get OFT-2 off the ground, a question was asked why something seemingly as mundane as ambient humidity in propellant lines was not caught earlier. NASA said the dew points last August were high, and the spacecraft was, of course, designed for humidity, but still had the corrosion problem. Humidity and Florida are as well known together as peanut butter and jelly. Spacecraft and rockets have been taking flight from this spaceport since the beginning of the space age. According to Kathy Leaders, NASA's Associate Administrator of Human Exploration and Operations Mission Directorate, Boeing and NASA have been asking that question themselves for the last 8 months. She said engineers went back and looked through all the subsystem reviews and other processes, and there were pretty aggressive lessons learned.
We learned something about how these valves worked. You know, they'd been through many tests, qualification, everything else, and we still learned something new.
Leaders said the team took what they learned and looked at all of the different kinds of valve designs throughout the spacecraft to find out where else the spacecraft might be susceptible.
Yeah, this was a susceptibility, or we didn't understand that you would have that tortuous migration, but this is teaching us that you can't assume that those connector pads and those other things are protecting you from this phenomena. This is a pretty aggressive phenomena, and so we will definitely take that learning in our future programs.
Now, it can be easy to blame Boeing or NASA for these seemingly simple problems, but let's not forget, even the first SpaceX Falcon 1 launches nearly 20 years ago had simple problems that doomed the whole flight. That being said, this isn't Boeing or NASA's first rodeo. All eyes are on the company to get OFT-2 right. While many test objectives were met during the first orbital flight test in December 2019, the main objectives that need to be accomplished for OFT-2 include rendezvousing and docking with the International Space Station. As of the publication of this video, OFT-2 is slated to launch at 22:54 UTC May 19th. That's 6:54 p.m. Eastern Daylight Time. Aboard is expected to be 225 kilograms of supplies for the crew already aboard the ISS. While OFT-2 is uncrewed, there will be an anthropomorphic test device wearing Boeing's custom flight suit. It's named Rosie the Rocketeer. It'll take about 15 minutes for the Atlas V rocket to place Starliner into a very long suborbital flight. It'll be up to the spacecraft to finish putting itself into a parking orbit around 31 minutes after leaving Florida. If all goes well, Starliner should rendezvous with the space station a day later, where it will dock with the forward port of the Harmony module. As things stand now, the spacecraft is expected to be docked for about 4 days, before leaving the outpost and returning to Earth around May 24th. It'll be returning about 275 kilograms of cargo from the space station. Starliner's prime landing location is White Sands Space Harbor in New Mexico. After a deorbit burn and re-entry into the atmosphere, which will slow the spacecraft down from orbital velocity to just a few hundred kilometers per hour, a series of drogue and main parachutes will deploy to decrease its descent rate to just a couple dozen kilometers per hour. Its touchdown will be cushioned using inflatable airbags. All of these dates and times are subject to change, so be sure to check in the description or your favorite space events calendar for updated information. Assuming the mission goes well, and I really hope it does, the next Starliner mission should be the crew flight test, which is now no earlier than late 2022. As things stand now, CFT would essentially be a copy of OFT-2, but with NASA astronauts aboard. After CFT, operational Starliner flights can begin, likely sometime in 2023. Even if there is another failure, the space agency has no intention to cancel Boeing's contract, according to Steve Stitch, NASA's Commercial Crew Program Manager.
We've been a partner with Boeing all the way through since the beginning of the Commercial Crew Program, the award of the TCAP contract, all the way through the investigation. Our intent is to have 2 certified space transportation systems and go fly the crewed flight test when we're ready after OFT-2, and we look at all the data, and then move on to the post-certification missions.
Since Russia's unprovoked invasion of Ukraine in February of this year, the need for 2 reliable commercial alternatives to the ISS has become even more critical. Should Crew Dragon become unavailable for a period of time, and if no American astronauts are flying on Russian Soyuz spacecraft, it's possible the ISS could go a brief time without the US segment being occupied. This has never happened before. There has always been at least 1 Russian cosmonaut and 1 American astronaut aboard at all times. This problem can be alleviated if a planned crew swap program continues, which would see a Russian cosmonaut fly on a commercial vehicle while an American astronaut flies aboard Soyuz. That way, if one spacecraft is delayed or grounded, there is still access for both countries. But with the ongoing aggression in Ukraine and the escalating war of words with the leader of the Russian space program, this seat swap plan is not certain to happen. If there are 2 commercial crew spacecraft and one suddenly becomes grounded for a long period of time, the other spacecraft can be readied as a replacement. This is the whole purpose of having dissimilar redundancy, so no one error causes months or years-long delays. Boeing's Starliner may also have a future beyond the ISS as a crew and cargo transportation vehicle for Blue Origin's planned Orbital Reef space station. While that is still many years away, it could be a way for Boeing to get customers beyond just government astronauts. While NASA does say it plans to stick with Starliner, if its problems do continue, I'm sure some other company could come along and say, chase the dream of flying people into space. Time will tell. But commercial transportation, both crew and cargo, are paving the way for future commercial space stations. NASA plans to replace the ISS with one or more commercial outposts before the end of the decade. You can find out more about this endeavor in this video right here. If you enjoyed this content, consider letting me know with a super thanks purchase. I'm trying to do this full time, and any support makes it easier for me to spend more time making more videos. Everybody who buys a super thanks will get their name in the next video I upload. Thanks again for watching, and until next time, Ad Astra.